People often ask me, as a theoretical physicist, when the universe will unveil its next great secret. My answer is simple. It already is. Right now, in this very moment, we are witnessing something extraordinary. A visitor from the frozen darkness between the stars, officially cataloged as 3I Atlas, is slicing through our part of the galaxy at astonishing speed. When it first appeared in July, it was nothing more than a faint shimmer in the cosmic background, barely noticeable even to the most powerful instruments. But now, that distant glimmer has transformed into something extraordinary, a living demonstration of cometary physics, magnetic chaos, and the relentless power of plasma storms. It's not just science unfolding before our eyes, it's a test of how deeply humanity can truly see and understand the cosmos. At this moment, 3I Atlas is less than 2 astronomical units from the Sun, tearing forward at nearly 60 kilometers per second and accelerating. When it slingshots around the Sun between October 29th and 31st, its speed could soar to nearly 68 kilometers per second. Imagine it, a cosmic traveler, flung out from some distant solar system, now plunging headlong into the violent radiation field of our own star. The coming days are critical. This is our one chance to capture what's really happening. On October 3rd, the object brushed past Mars, sweeping within a mere quarter of the Earth-Sun distance, a near-perfect alignment. And that alignment gives us an extraordinary advantage. Every robotic probe orbiting Mars is now in prime position to observe the event. Call it a stroke of cosmic luck. Just as Earth's view becomes blinded by solar glare, Mars steps in to give us front-row access. Europe's Mars Express and ExoMars Trace Gas Orbiter are already armed for high-resolution imaging and chemical scans. Meanwhile, America's Mars Reconnaissance Orbiter, equipped with its legendary high-rise camera, and MAVEN, the atmospheric sentinel, are poised for equally valuable readings. Yet curiously, some of these data channels have gone silent. The U.S. federal funding freeze has left certain information streams eerily quiet. Still, China's Tianwen-1 and the UAE's HOPE probe could provide independent verification if their teams can reposition their instruments in time. That's the beauty and the burden of real science, confirmation through parallel observation. It's what separates speculation from truth. So what exactly are we detecting? Let's start with light. 3I Atlas has now brightened to around magnitude 12, invisible to the naked eye, yes, but easily spotted through a decent backyard telescope. What's truly intriguing, though, is how its brightness began to deviate from all predictions in early September. Right as it crossed the 2 astronomical unit mark from the Sun, that's when the numbers stopped behaving and the mystery deepened. It's glowing far more intensely than anyone predicted, brighter than the models ever suggested. Part of this anomaly likely comes down to differences in measurement, how each observatory captures and processes the faint light spilling from an expanding gas cloud. Telescope size, exposure duration, and image processing all play a role. But then came something extraordinary. On October 2nd, NASA's Perseverance rover caught a glimpse of something no one expected. During a 9-minute series of long exposure images taken under the Martian night sky, the rover's cameras recorded a thin diagonal streak cutting cleanly across the vertical star trails caused by Mars's rotation. That streak wasn't a glitch. It appeared again and again across consecutive frames, stretching in a pattern that perfectly fits the motion of a fast-moving interplanetary object. Random cosmic rays don't behave like that. Neither do Martian moons. Not at those speeds, not at those angles. And when scientists checked the timing and trajectory, the data lined up shockingly well. Everything pointed toward one possibility. The streak could be 3I Atlas itself, racing through Perseverance's field of view. The resolution may be modest, yes, but the implications electrifying. This is how real discovery happens, piece by piece, frame by frame, each one demanding independent confirmation before the full picture comes into focus. Now, the challenge shifts to orbital geometry. On October 21st, we reach superior conjunction, when the Sun sits directly between Earth and 3I Atlas, creating an almost perfect alignment. From here on Earth, we'll be completely blinded. Ground-based telescopes will drown in solar glare, unable to see anything at all. And here lies one of astronomy's most ironic truths. Humanity can photograph the shadow of a supermassive black hole millions of light years away. Yet a small rocky visitor just beyond Mars disappears the instant it drifts too close to the sun's glare. That's why the Martian observation window is so critically important. Then comes the moment of truth. Perihelion, between October 29th and 31st, when 3i Atlas will swing to just 0.36 astronomical units from the Sun. If it's planning any kind of dramatic encore, whether explosive gas jets, sudden fragmentation, a flare of light, or an eerie dimming, physics will demand that it happens right then. After this fiery encounter, Europe's JUICE spacecraft will take over, continuing long-range monitoring from deeper inside the solar system. The geometry is ideal, though communication constraints mean much of that data may not reach public archives until early 2026. Science, after all, often feels like a relay race, one team passing the torch to the next, each chasing the truth through time and distance. We pass the baton for months, even years, when rigorous methods demand patience. Now let's zoom out. In less than a decade, humanity has met 3 confirmed interstellar visitors: Oumuamua, Boris, and now 3i Atlas. Each breaks the rules in its own way. Right now, 3i Atlas is our teacher. It shows us how frozen interstellar stuff wakes up under fierce sunlight at extreme speeds, how dust and ionized gas organize themselves into sunward structures, and how a gas envelope can activate almost instantly, like flipping a switch. That diagonal streak caught by Perseverance hints at pure motion, raw kinematics in action. Next, spectrometers on Mars Express and the Trace Gas Orbiter will hunt for the source of that eerie green glow. Are we seeing classic swan band carbon-2 emissions, or is this a look-alike caused by plasma effects and photochemical breakdown? The brightness curve will tell us whether this surge is a brief outburst or a sustained climb toward the sun. Beneath all the graphs lies a quiet truth. We, tiny beings on a fragile blue world, built a surveillance network around another planet so that for a few precious days we could watch a traveler from beyond our star system thunder past our neighborhood. When I was a kid, comets were framed as cosmic omens. Today I see them as mobile laboratories. 3i Atlas may never paint the twilight with a blazing tail, but in its data, the spectral lines, the stacked images, the geometry of its sunward plume, there is something that outlasts superstition: knowledge, real understanding. If you want to see how science truly advances, watch this investigation closely. Progress doesn't come from loud certainty. It comes from careful plots marked with honest error bars. It doesn't grow from grand pronouncements, it grows from the courage to accept the unexpected. In a few weeks, 3i Atlas will slip behind the sun from Earth's point of view, gone for a moment. In December, it will return to our sky, changed by its trial through solar fire. We'll measure again. We'll compare before and after. And someday, maybe sooner than we think, a doctoral thesis will start with a simple line: we uncovered something foundational about interstellar visitors by studying 3i Atlas. That paper will cite the Martian observation campaign, the Namibian image stacks, the Perseverance diagonal streak, the 2AU brightness anomaly, the emerald gas envelope, the anti-tail, and the perihelion behavior. Another page in our cosmic encyclopedia complete. Until then, be patient, stay skeptical, and stay endlessly curious. The universe doesn't promise simplicity. It does promise consistency. And inside that consistency, physics lays its groundwork. Our instruments and our imagination are ready, listening.